Today's lesson, laboratory preparation of ammonia. Ammonia, the key ingredient of glass cleaner. Let's go to the detail. Ammonia, the molecular formula is NH3. Physical state of this compound is gaseous and its name is ammonia. This word is taken from the worshippers of Egyptian god Amun. This is also known as azane. Azane, a saturated compound composed of nitrogen and hydrogen. Its structure formula is the shape is trigonal pyramidal. This is about ammonia molecule. In this lesson, we are going to learn two methods of laboratory preparation of ammonia. Let's see the methods one by one. Method 1. In this method, ammonia is prepared from the mixture of ammonium chloride and calcium chloride. Calcium oxide. Here, this is the setting to prepare ammonia in the laboratory. This is the test tube where this mixture is taken. Mixture of ammonium chloride and calcium oxide. Here, this is a delivery tube. At the top end of the delivery tube, another test tube is set inverted upside down. When this mixture is heated, then ammonia gas is produced. Let's see the reaction. Ammonium chloride plus calcium oxide. When this mixture is heated here, then calcium chloride is formed, which is solid. At the same time, ammonia gas and water vapor are produced. That is collected in this test tube by downward displacement of air, because density of ammonia is 0.73 kg per cubic meter and density of air is 1.225 kg per cubic meter. From this data, we can say that ammonia is lighter than air. That is why ammonia is collected by downward displacement of air. So here we got a gaseous mixture. That is actually mixture of two gases, ammonia and water vapor. This is one method by which we can prepare ammonia gas. Let's see another method. Method 2. In this method, ammonia is prepared from the mixture of ammonium chloride and calcium hydroxide. Ammonium chloride and calcium hydroxide. In the similar way, here this mixture is taken, that is mixture of ammonium chloride and calcium hydroxide. When this mixture is heated, then reaction happens. Ammonium chloride, calcium hydroxide. Then calcium chloride is formed, which is solid, and it remains inside this test tube. And two gases, ammonia gas and water vapor are formed. This mixture goes to this test tube where it is collected by downward displacement of air. Now the point is separation of ammonia from the mixture of ammonia and water vapor. Now the point is collection of ammonia from the mixture of ammonia and water vapor. When ammonia gas and water vapor is passed through calcium chloride, then calcium chloride reacts with oxygen and hydrochloric acid and calcium oxide is formed. That is, water is separated by calcium chloride. This is a kind of hygroscopic substance. Hygroscopic means tending to absorb moisture from air. At the same time, calcium chloride reacts with this ammonia and forms calcium chloride octaamine, which is a kind of complex compound. So, using calcium chloride, ammonia gas cannot be separated. Let's see another process to separate ammonia gas from the mixture of ammonia and water vapor. In this process, the mixture of ammonia and water vapor is passed over quicklime. This mixture is passed over quicklime, calcium oxide, which is known as hot lime and burnt lime as well. In this case, calcium oxide reacts with only water, and as a result, calcium hydroxide is formed. Quicklime is basic in nature. This is also basic in nature. This is basic compound. This is basic compound as well. That is why calcium oxide doesn't react with ammonia. Calcium oxide only reacts with water to form calcium hydroxide, which is solid in state. So, ammonia gas remains unreacted and this is separated. In this way, we can separate ammonia from the mixture of ammonia and water vapor. After this separation of ammonia, this ammonia is dissolved in water. Here, ammonia undergoes hydrolysis, and as a result, ammonium hydroxide is formed, aqueous, the key component of glass cleaner. This is all about preparation of ammonia. Thank you very much.